VLPSos here. This is a video lesson for Python programming, step movement. This code began with stub 2. I have written already into this code file a class called object, attributes being x position, y position, step, and size. And we're going to use this class to make a single instance, and that instance is going to be simply a square on the screen. But what we're going to code for is moving that square. And the way that we're going to move it is in incremental steps. With a step of 10, the step attribute of 10, that means that we're going to move with the pressing of a key the position of the square that represents this instance on the screen by intervals of 10 pixels at a time. One key press, one step. And we'll move it or make it capable of moving in 4 different directions with different keys. I've added a few more things to the stub to get going. I have an instance that I placed in a dictionary called things. This is a good way to begin coding. We're not going to make more than one instance, but we've prepared the way to make more instances if we wish. In the frame loop, I have comments. I haven't coded yet a place for moving the objects. We're going to have a method to do stepped movement based on descriptive string values. And then we're going to change the algorithm a little bit for the same effect, but we're going to implement the use of booleans in order to make the change in position happen. In the event queue, the stub has separated out and given us some information and some reminders. And I've added a few more numbers for key presses that we'll implement. But we have the event queue, which is the for loop that processes the events that during the frame got loaded up in memory, and this is what we're responding to as the user input, the place where we check those to see if there's anything meaningful to our program. Meaningful would be an event type like the pressing down of the key. And the stub, or where we're starting, offers a reminder that the escape key is key number 27, and that would change the Boolean that runs our frame loop. But there are several more specific key press numbers, very large integer values for the arrow keys on the keyboard, left, right, up, and down. We also have left shift in the stub, and common keys A, D, S, and W for 4-directional movement. We're going to implement a response to each of these key down events. We also have one event for key up, the left shift. Ready, doesn't do anything. That's why we have the pass word there as a placeholder. And if we press the mouse buttons down, we would get a location printed of where we were pressing on the screen, and an event type mouse button up, which does nothing. So we have a format that we can fill in for our coding intentions. The first thing that we're going to do is we're going to implement movement based on a description. What that means is using a string to describe the kind of movement that we're implementing. For example, if the left arrow key was pressed, then we could make a variable called take step and have that be equal to the string left. The string value of take step is literally the intention of what we want to accomplish. The user sees our object move to the left. So if we've chosen take step to be the variable whose value describes the kind of movement that we want, then we would assign a different value to the same variable based on the key press that we're getting. Press the right arrow key, the take step value becomes the string right. And up for up, down for down. So if we complete the code for those 4 types of key down events, then what we have is we have the pressing of the arrow keys then make the assign the take step value the movement that we wish. So now that take step represents that kind of movement, we need to respond to it in our frame loop under the comment move objects. We've got 2 different algorithms that we're going to do this. The first one is based on descriptive string values. So if take step has any value at all, it's a string, but if there's any value to the variable take step, then this as a condition will be true. So if take step has any value, then we can go through checking what that value is and responding to it. If it's left, then what we want to do is move the position of the instance of our object, which is in the dictionary things. So we refer to things with the key of the only object that we have in here, and left is a horizontal effect. So it would be the x position attribute, and moving to the left means that the x coordinate of where we're going to draw the square to represent this is going to be less in order to move that position to the left. So we're going to subtract and reassign the x position by the amount of its step attribute with a 0. X position and step are attributes of our class, and we're using the attribute step to be the amount of pixels that the position is going to change by. In this case, I believe our value was set at 10. So that's how to accomplish left movement. We've coded a little bit. It would be worth checking for errors. There we have the square that's representing our instance, and if I press the left arrow key, I haven't quite got the movement algorithm complete even for going to the left. Thing is not defined because the dictionary was called things. But before I check it again, I'm going to copy this code that I worked out for moving left, and I'm going to take away the description so that I can copy it 2 more times before filling in for the 4 positions left, right, up, and down. Moving right is also a horizontal change, so it's going to change the x position, but up and down is a vertical change, so I want to change these to the y position attribute that's changing. And each one is going to change by the same amount, the step attribute. However, going right is going to add to the x position. Going up is going to subtract, but going down is also going to add, but to the y position. And since take step can only be assigned 1 string value, it would be best to make these elifs. So once the condition is assigned to be true, it doesn't have to check the others, and it saves a little bit of processing time. Let's check to see what we got. I'm pressing the arrow keys, and it seemed to have gone off the screen, and it might have flashed if I pressed then. I first pressed to the left, and then I pressed to the right. So what's going on? We didn't get a single step in the sense that it took 1 10 pixel movement per press of key is our intention. And it's not doing that. Why? Because once I press a key, I give a value to take step. And that value remains. So the next time I come back to this place in my code in the frame loop, then take step remains that value. And I continue to take steps as fast as my frame loop can process. So how do I do this so that it only takes one step until I press a key to take another step? What I need to do is after I have taken my step, before I move on, I need to reassign that variable to not have any value. So here, take step is equal to none, literally erases the value of take step, and this condition here would be false because take step has no value at all. A key press will give it a value. It'll be a string value, one of these 4 strings that describe the motion, and then it'll go through this algorithm again, but only once, and then be none again, so it will not repeat until I press another key. Let's see if that solves our problem. I have the initial position, and I'm going to press the left key, and I can see that I'm pressing it repeatedly, and I get the motion once per press. I can also go up and to the right and down. But if I press down and to the right at the same time, I don't always get the oblique motion down and to the right. The steps are independent of each other the way that I have it programmed now. Okay, let's change our algorithm a little bit and base this step movement on Booleans. I'm going to go back to my input queue and I'm going to choose a different 4 keys to represent this new type of movement, though the effect is going to be the same from the user's perspective. Basing it on Booleans means that the pressing of a key is going to assign a Boolean to be equal to true. In this case, A is going to be for left movement. So I could say step underscore left is equal to true. So the variable itself, not its value, is more of a description about the kind of movement that I would get from it. So if I'm going to have 4 directional movement, I'm going to need 4 different variables, one for each movement. D is associated with down. Well, S is. D is right. And W is up. The pressing of the keys now assign one of 4 variables to be true. A true value is the sense that we could think of it as it is true. If we change step left to be true, then we're thinking it is true that a step left ought to be taken. So if we have these Booleans, we got to be careful if we're referring to them. It's a very good habit to, before our frame loop, declare these variables before they're used in your code. In case, it's a good habit to be in, because very often we might be checking the value of a Boolean before it was assigned. And we would be doing that because we're going to respond to these Boolean values in the frame loop here, and this would be before they would be assigned in the event queue that happens after this section of code. So we will need an initial value for these Booleans. Step left, right, and up and down to avoid an error the first time we run our code. Now that we have the Booleans ready, we're going to respond to them in our movement algorithm under this line of code. We could say if step left is true, then we're going to change the position in the very same way that we did based on the description, the string descriptions. And like before, to save some time, if I know that I'm going to use this once for each direction, I can copy and paste it. I'm not going to put these in elifs because I want it to be possible now that I could have downward motion and left motion needed to be done in the same frame. So these are independent if statements and independent conditions, so two of them can happen in the same frame. But I do want one for right, up, and down. And rightward motion is going to add to the x position. Up and down are y position changes. Up subtracts from y. Down adds to y. Let's see if we got what we want. Still have the arrow key step movement happening, but now I'm going to press the D key. And we scooted off the screen really fast. I'm going to press the A key, but it doesn't come back. What's happening? If I press the A key when I tested it, then the A key is associated with, well, it was the D key first, and that's associated with rightward movement. So step right was true if we saw it scoot off the screen really fast to the right. The X position was changing by adding something. But if we think about that happening and then coming back around to our frame loop again, then the next time, just like before, step right is still true. So it's going to continue to go to the right every single frame once I press that key. In order to make this happen only once, I need to reassign that Boolean to be false. So it's immediately made false and the rest of the code block is only executed once because I've got to get another key press in order for it to be true again and do the code block another time. So we get this once per key press. Every Boolean needs to be turned back false once the condition is true. The best place to do this is immediately after the condition tests true if you want the code block to run only once. Let's see if we got what we wanted. Arrow keys still work, and now A, S, D, and W. The last thing that we're going to do is we're going to code for the shift key being held down as a way of increasing how much we move by, sort of like an enhanced step. So there's two different step sizes. We'll call them strides. One that's normal movement, and one is when you press the keys, but the shift key is also being held down while you press a movement key. In order to prepare for that, in the event queue, we're going to go to the place where we already have a stub for the pressing down of the left shift key. And when we do, we're going to make a Boolean called big step to be equal to true. So the pressing down of the left shift key will make big step equal true. Now we want it to stop stepping or changing the stride amount when we release the left shift key. So we're going to immediately go to where our event queue is testing for key up events, and the release of the shift key will then make that big step variable false. So we have a variable called big step. We press the key and that Boolean is true. But the Boolean isn't going to be made false immediately after we use it, just like our movement keys. In this case, the way that we turn off a big step is we release the shift key. It's only on the event, this event here, a key up event, that big step becomes false. It's like the holding down of the shift affects it, and releasing it then stops that effect. Big step, being a Boolean, needs to have it, we need to declare it and set an initial value so that we don't get an error trying to use it before it can be assigned in our event queue. So we'll start with the big step being equal to false. And how does it affect our movement? Before we base our movement on Booleans, we'll add it to a part of the based on Booleans. We're going to say if big step is equal to true, then we're going to invent this variable called stride. And stride will be equal to 3 times the attribute of step. So whatever the step attribute is of our instance, big step is 3 times that amount. And if it's not true, else, then our stride is going to be simply equal to the step. Now we have created stride to be the amount that we change our position by, not the step, because stride can be different. So I'm going to copy just the stride, and instead of basing the change in X and Y position on step, it's now stride, because it's possible for there to be 2 different stride values. Let's run it. I still have the arrow key movement with the small stride. I have the WASD movement with the small stride, but at the same time, if I hold down the shift and press the WASD keys, I move by a larger step, more pixels. If I keep holding the shift and I press my arrow keys, I still get that smaller step movement because the arrow key movement isn't based on this new stride amount. It's still based on the step, the attribute of the class. And if I release the shift, it goes back for the WASD keys being a small movement. Now you have seen how simple movement involving key presses to change the position of an on-screen object by small amounts can be accomplished in 2 different ways. Use this code file as a stub and add a way to step in the 4 oblique, some would use the word diagonal directions. In other words, upright, up left, down right, and down left. There are a variety of ways to accomplish this. Make sure to include a way for someone using your program to understand what they are supposed to do. Instructions given as a comment at the top of the code file is fine. You don't have to explain how to do this on screen to the user, but include in your code what keys to press or whatever is necessary so that it can be tested. This movement is 4-directional, so the now U is having you change it to be 8-directional movement. Have fun.